Hi everyone, just a quick update. I have a alternator hooked up to the motor shaft directly, and we'll take an RPM reading right now before we start anything. So we're at 2,265 RPM. So it does take some extra power to turn that motor. So basically each phase is around 24.3 volts and utilizing 386 milliamps, and that comes up to just a little over 9 watts. So about 9 watts going through each phase. And then don't forget we have then the flyback coming up as well, fairly high, much higher by increasing the input. I can't really calculate that because it's just now going to batteries. This is just a quick update. This is nothing, just a bit like a little teaser, I guess. So there is the scope shot. I'll get my cardboard here. So there are the multiple phases there, and I'll go in a little bit there, give you a shot on 3 phases. And that is presently not under load. So now I have here a precision resistor. Sorry about that. That is a 5 ohm resistor, 1% resistor. And I have a true RMS multimeter here. This is a perfect sine wave coming out of this. So I'm now going to put this under load. Let's just check once again what we're using here is power consumption. So 24.3 volts is the input at 386 milliamps. So I'm going to go ahead and put the 5 ohm load resistor on. So the RPM does go down because the circuit is not giving it more current or anything like that, and that's the reason why the current maintains the same. So as you see, nothing has changed. The consumption is identical. And there you go. So let's now take a, wow, that's the first time I ever had focus problems. Let's now take a RPM reading here. So we're down to about close to 1,900 basically. And nothing has changed, and there is our scope shot. There are more samples there, and I guess a lot of you are wondering how much is across that load resistor. We shall put these terminals here and check that out. 4.98 volts RMS across that resistor. That is 5 watts. So we're delivering 5 watts to a load without affecting the input of this motor. And the other thing that's interesting is if you have a look at the, I'm going to zoom in here. What you're seeing here in green, that is the current. And there's a pretty fast rise time on the current, but look how beautifully flat that current is. So this actually reminds me of the Orbital. And what I'll go through now is I'll move it with the cursor there to see the next phase. That is the next phase. It is also very, very flat. So perfectly flat tops. I don't know, that to me suggests a lot less counter EMF, and that was what was also claimed with the Orbital. So these reluctance motors seem to be very good for that, you know. So that's one thing I did notice is these very flat current tops. And the other bonus is obviously, you know, you're putting the device on load. So I'll remove the load resistor now. That is the voltage and current there. Jeez, it's got a lot of glare here. So now I'll remove it. You can hear the RPM go back and nothing has changed. And there is the view of the waveforms there. It's just the RPM that changes. So now I'll put it on load. So just the RPM reduces, nothing else changes. And there you go. Thought that was interesting, and just the first really of other tests that are to come. And thanks for your interest. Bye now.